A very good morning to all of you. Welcome to the ATAL Faculty Development Program on Cross-Modality Innovation, Generative AI in Language, Image Intelligence, and Medical Advancements. Now we will proceed for session 1 of day 5, Advancements in NLP, Exploring Generative Models for Text. It gives me immense pleasure to extend a warm and heartfelt welcome for this session to our esteemed resource person, Professor Archana Singhal, Department of Computer Science, Indraprastha College for Women, University of Delhi. Professor Singhal is a renowned expert in the field of natural language processing, cloud computing, text analysis, semantic web, multi-agent system, agile development, intelligent software engineering, secure software systems, information retrieval, and ontologies. With over 25 years of teaching and research experience, she has published more than 60 research papers in different areas of national, international journals and also participated in many conferences. She has been a part of various research committees across University of Delhi. She has been a resource person and a coordinator in summer internship program on web design and development organized by University of Delhi and Tonmong University, Busan, South Korea. Funded by IITP, Ministry of Science and Technology, Government of Korea. She has also guided more than 10 PhD students. We are truly honored to have you, ma'am, with us today for this session. Welcome, ma'am, and over to you. Ma'am, are you
Thank
able to
you,
hear? Thank you so
Raj.
much, ma'am, for joining and for sharing. You can proceed with the session, ma'am.
Okay. Thank you, Rakhi, for giving me such a good introduction. First of all, I would like to congratulate Bharti Vidyapith for organizing such innovative FDPs. Actually,
Thank
they
you,
are
ma'am.
very much required.
Yes, ma'am.
Am I audible?
Yes, ma'am, you are properly
Yes,
audible.
ma'am. Good morning, ma'am. Thank you so much for joining. This is Dr. Deepika here.
Thank you. So, congratulations again for organizing such a good FDP. Then I would like to thank all of you, all the organizers, for inviting me in this session and sharing my knowledge and experiences. Okay, let me share my presentation.
Yes, ma'am.
Is it visible?
Yes, ma'am, it is visible.
Okay. Good morning to one and all present here. As you already know the topic of today, these are the table of contents. First, I would be actually introducing about the AI and the natural language processing. Then I would be discussing a brief history. Actually, I would be discussing the noticeable advancement in NLP, which basically led to the development of these generative text models. Okay. So, and there are a number of generative text model machinery nowadays. I would be discussing only few of them, which are most recognized and used. Okay. And I would be discussing certain limitations of using these models, then the challenges in generating these models, then ethical responsibilities, whether we are using it as a developer, as a user, we have certain ethical responsibilities associated. So I would be writing few of them, then the considerations, and finally the conclusion. So let's first start the basic introduction. What is AI? So as the name suggests, this is artificial intelligence. It means we are trying to make the machine intelligent. They can behave like human beings. So basically, we are trying to mimic human behavior in machines. Then we are expecting the machines to do the task that is normally expected. by the human being, like pattern recognition, some decision making, game playing. Okay, so special tasks which are basically expected to do by the human beings. Now, AI has become an integral part of our day-to-day life. So, like everyone is using AI in life, even without knowing about it. Okay, it has become like it has been integrated in our daily life. We are not even imagining that we are using it. Like whether it's using smartphones, or we are using social media platform, or we are making online shopping, or we are navigating while traveling. You name the thing, AI is there. This is a basically study done by Precedence Research. This is on artificial intelligence market size growth from 2023 to 2034. And you can see they are predicting market size from $538 billion to $3,680 billion from 2024 to 2034. So see, this is expanding as a compounded annual growth rate of approximately 19.1%. And there is another study by Nielsen Norman Group. Basically, they have made this study on the use of AI in the software development, and thereby seeing the notable positive impact on that. There are 3 studies. The first study is basically when support agents, they are using AI systems, and they can handle 13.8% more customer inquiries per hour. In the second study about business professionals who were using AI, they could write 59% more business documents per hour. Then in the third studies, the programmers who were using AI in the systems, they were managed to write 126% more codes, like they were more productive than earlier. To see the notable difference. Now, what is NLP? Natural language processing, which is a branch of AI. So let me first start. What are the natural languages? First, we understand the natural languages. Then we can understand why do we need natural language processing. So natural languages are the day-to-day language which we are using for the communication. And they are not the specialized languages which we use for the computer. So computer cannot directly understand this natural language. So natural language processing is an area, it's making a technology that is training the computer to communicate with the human beings just like we are communicating with each other. When we talk about natural language processing, basically it has got 2 components. One is natural language understanding, and second is natural language generation. In natural language understanding, basically what we are trying to do, we are training the computers, building the technologies, so computer can understand the natural language. So what a human is saying, computer can understand and process that. And this process requires the 3 steps: syntactic analysis, semantic analysis, and discourse analysis. And syntactic analysis is basically referring to the grammatical aspect of the language. Okay, because before processing a sentence or a text, first a grammatical part is looked upon. First, it will check whether this sentence is grammatically correct or not. So some internal representation is created using certain techniques. Okay, then relationship is established between them. Then to find the meaning, a semantic analysis is performed. And finally, to get the intended meaning as per the context of the given text, discourse analysis is done. So these are the basic steps basically. While on the other hand, if we look for the natural language generation, it is other way around. While in NLU, we are trying to make it easier for the machine to understand what people are saying. In NLG, we are trying to make it easier for the people to understand what machine is saying. So that is the area basically natural language generation. And again, there are three components: when to say, what to say, and how to say. And if you look in these three aspects, the third part, how to say, this is the most difficult part, because machine only not has to present grammatically and semantically correct sentence, but it should be represented in a form which is clearly understood by the user of that machine. So it is the most difficult part. Now, why it is easy for the human being to understand or to communicate in natural languages, but difficult for the machine to understand. So let's find out some characteristics of the natural languages which makes it difficult for the machine to understand and to process it. So there are few important characteristics: ambiguity, incompleteness, imprecision, inaccuracy. So what is ambiguity? Natural languages are inherently ambiguous. So they have got various situations in which there are ambiguity in a text. Like sometimes they have multiple word meaning. Look at these two examples. Pitcher is angry and pitcher is empty. In these two sentences, we are having this word pitcher. But in the first sentence, the meaning is different. It is basically referring to a baseball player. And the second sentence, pitcher is referring to a container. So meaning in both these sentences are different. So how the computer will interpret it without knowing the context and familiarity of the word in the context which appears, it's very difficult for the computer to understand it. Similarly, there might be different types of syntactic ambiguity in the text, like phrasal associativity or unclear association between antecedent and anaphora. So look at these examples. The first example, I hit the man with the hammer. How will you interpret it? I picked up the hammer and hit the man, or I hit the man who was holding him. Okay, because there are multiple meaning of this. And in the second sentence, which is an example of association between antecedent and anaphorus, John hit Bill because he sympathized with Mary. So what he is referring to, whether it is referring to John or it is referring to Bill. So without knowing the clear situation or the context or the familiarity of the situation in which these sentences are going to appear, it's very difficult for the machine to interpret sentences. So handling ambiguity is another aspect. So we have to train the machine to communicate with human beings in the natural languages. Another important aspect is precision, because many times we are presenting the natural language text without precision. Look at these three examples. I have been waiting in doctor's room for a long time. And second is the crops died because it didn't rain for a long time. And third is the dinosaur ruled the earth long time ago. So you see, in all three sentences, we are using the word long time, but it has got a different meaning, because long time in the doctor's rooms, it means waiting only for a few hours, not more than that. But when we're talking about the clocks, it means we're talking about the months or the years. But when we are talking about the long time in context of dinosaurs, then we are talking
Really, the thousand of years. So long time has a different context in all three sentences. So without familiarity of the situation and the context in which these sentences are going to appear, it's very difficult for the computer to understand and interpret sentences. And one more problem is incompleteness, because many times we are presenting the text which is not complete and we expect the others to fill it. So this is a very famous sentence by Ellen Ritchie to explain the concept of incompleteness. John went out to a restaurant last night. He ordered steak. When he paid for it, he was running out of money. So the question is, did John eat steak? What is the answer of this? You can clearly make out the answer is yes. But it is as easy for the human being, not that easy for the machine. Because this is not explicitly mentioned in the paragraph. Okay. Only if all the context, familiarity with the situation, everything is provided to the computer, only then it can understand the actual meaning and answer this question. Sometimes we are also presenting the sentences which are not grammatically correct, but humans can make out whether it is correct or not and what is the meaning we are trying to convey. But it is not directly possible for the machine. So basically, it is very relevant or very much required to study the human behavior, how humans can deal with all these ambiguities with the ease. Okay, so machine can also understand and process these ambiguities and use these texts without any problem. So how to deal with it? A great amount of knowledge is required to, to offer to the computer. And we should have a way also to represent this knowledge in a way so we can easily understand it. So various advancements in LLP now have changed the machines, how they understand and interact with the human languages. So basically, the core technology behind all the noticeable advances in NLP is machine learning, especially deep learning. What is machine learning? It's the capability of a machine to learn with the environment. And deep learning is a basically a class of machine learning that uses more complex networks and algorithms to analyze the data. So we can say deep learning is an evolution of machine learning. Whenever you are using machine learning algorithms and you require some connection, you find some problem, then human intervention is required. But in deep learning algorithms, you don't require human intervention because they learn by itself, by the repetition, by the time. So this is a simple diagram basically depicting this machine learning and deep learning. Now, when we talk about the learning, basically there are different type of learning when you are training the model. It might be a supervised learning or unsupervised learning or a special class of learning, which is a reinforcement learning. So what is a supervised learning? When we are training a model by giving the label data, you have a label data and for every input you have a correct output and we are providing it to the machine. The simple examples are classification and regression. And we are also using supervised learning in life. You can find many examples. We all are teachers. We are teaching in a class and you are providing some problem to the student. When you are guiding the student step by step, you are telling the student all these step one by one how to solve the particular problem. Then this is an example of a supervised learning. Another type of learning is unsupervised. In unsupervised learning, we are not using any label. What we are doing basically now, model is basically categorizing the data based on its features. So it basically categorizing using the similarity and the differences between the data. And very standard example is clustering. Now another special type of learning is reinforcement learning, which is very important. It is a basically now it gets very machine learning algorithm. How the machine learn in reinforcement learning basically trial and error. Actually, they are assigned certain tasks to perform, and based on their outcome, whatever they are, how they're reacting with the actions, what is their outcome, they are rewarded positively or negatively. So if they are given positive rewards, it means they are encouraged to perform those actions in future. And if they are giving negative reward, it means they are discouraged. Okay. And you can also find real life example for all these learning because they are all inspired by the human brain only. What is the example of reinforcement learning? You are teaching in a class, and a student is submitting his test or his assignment in time and getting good marks, you can appreciate the student. Very done. Well done. Keep it up. Okay, so you are encouraging the student. Or supposing a child is playing, and after finishing playing, it's organized into a shell for each. Okay, and you say good, good, and you reward the child giving some reward to it. So this is again an example of reinforcement learning because you are basically encouraging to do those actions which are positive. So see, the first one it is an example of supervised learning, and the second one is an example of unsupervised learning because a student is trying to learn by itself without intervention of teacher. So this is basically a diagram of reinforcement learning where there are agents and they are performing some actions in the environment, and based on their outcome, basically we are rewarded positively or negatively. So now this is the diagram depicting the difference between all these three types of learning. You see, because in the supervised learning, you are having label data. Okay, so it's a kind of mapping because you are providing every input with a direct output. So it's a kind of mapping. In unsupervised learning, you don't have any label data, but encouraging the model to categorize the data based on its feature. Okay, so it's a classification. Then the third type of learning, I have already explained, working on the rewards. Basically, we are giving the rewards, positive or negative, and depending on that, the model is learning. It has to take the action in the near future or not, depending on a particular context. Now, I would be discussing a brief history of the NLP experiment. Only I would be discussing the some of the advances, which are basically used or they are responsible for the generative text model. So this is not a new concept actually. In 1993, Georges he created a device called mechanical brain. Think in 1933, back in 1933, they already introduced this idea, the translation between the language. So it was kind of a mechanical translation. Like we use a multilingual dictionary, we want to translate from one sentence or word from one language to another language. So basically, it was kind of a multilingual dictionary which was using for translation between the languages. Then in 1950, the Arthur Samuel, a renowned scientist, he developed a first machine learning algorithm for playing checkers. So he came up with the phrase machine learning. In 1957, Noam Chomsky, which is basically also called the father of linguistics, because he was a renowned scientist in this area. He basically presented a syntactic structure, and which was referred as universal grammar. Why it was referred to as universal grammar? Because he believes that all the languages have something in common, and humans are born with the natural instinct of learning those languages. They don't require any training to learn those languages. So he suggests we can generate a universal structure of a grammar which can be used to generate the sentences in any language by passing some language specific parameters. So this was a very good feature. And when I was doing my PhD, I also implemented this universal structure in my work, and it was a very successful experiment. Then way back in 1966, Joseph Weizenbaum developed first ever chatbot called Eliza. And this Eliza basically, it was a chatbot which was using a pattern matching. It doesn't know much actually. Actually, how it works basically, it just just pass the input given by the user of the that system, and basically it paired it with the scripted responses. Okay, so just follows the simple rules to mimic the human behavior. And just basically it was resembling some psychotherapist. Then in 1980s, recurrent neural network was introduced by the researchers David Rumelhart, Geoffrey Hinton, Ronald Williams, and basically they lay the foundation for the advancement in processing the natural languages. Then around 2000, neural probabilistic language models they were introduced, which were using feed-forward neural network, which is basically a building block of the natural language processing applications. It has got an input layer, it has got an output layer, then in between there are so many hidden layers. So when we are passing the input, it is passed through different hidden layers, and every layer is processing the which is given by the previous layer and applying some non-linear transformations. So we get more conceptual and more relevant data after passing layers. Then in 2017, the concept of transformer was introduced, which was a revolution in the field of natural language. He presented a paper, Ashish Vishwani presented a paper, which was basically a member of Google Brain. Attention is all you need. And this paper addresses the limitations of the traditional sequence to sequence model. Actually, he advocated the advantages of the transformer, okay, how they better than traditional sequence to sequence model and how they are used in the very natural language processing. So I would be because transformer model is revolutionary model discussing some models that are based on the transformer, like BERT. So I would be discussing this BERT in detail, which was introduced by the Google researchers. So first, let me introduce the transformers, how they are better than traditional models. So why they are replacing the traditional convolution and recurrent neural network. So basically, these earlier models they have some limitations, and one of the main limitation was they are processing the information sequentially because they operate in timestamp manner, like processing one token at a time, and then maintain some hidden state that carries the information forward. But the major problem, apart from because of the sequential processing, it was a vanishing gradient problem. Actually, because they are processing the data sequentially, and it is a long sequence, they are prone to forgetting the distance information, which was the major problem. Now, why transformers are better? Because they eliminate the need of sequential processing, because they support a parallel architecture, and because of that, they process the entire sequence simultaneously, which significantly improves the processing time, making it more efficient, particularly for long sequences. And also because we are not passing any label data to these transformers, they need less time. Because earlier models, when you have to pass the label data, you need huge amount of data to train these models. So computational time is very large. But advantage of transformer is they don't need training data. So making them more efficient in processing the long data. Basically, what are the key innovations that made transformers so popular? Basically, there are two innovations, positional encoding and self-attention. What is positional in the text? When it's processing the text, a unique number is assigned to each word, or we can say each token. When it considers the information, it assigns a number, which is basically the positional encoding, which it is using. Then self-attention mechanism, which is a very important mechanism in the transformer. It calculates the weight of every word in the sentence, how this word is related to other sentence, and how it is important, what is the weight of this. So accordingly, it finds the different words, how they are related to each other or other sentences in the same text. And this self-attention mechanism basically allow each word to attend every other word. So it's using multi-head attention basically. So it's become very fast. So there are few basic key steps how these transformer models are working. Like first step is the input embedding. Like after pre-processing the text which is given, some embedding are done. The first is input embedding. It is transformed into the numerical representations, which capture the embedding meaning into the token. Then positional encoding is done, which is basically done by assigning the numerical value to these tokens. Then multi-head attention. As I told you, it works on the self-attention mechanism. So it utilizes multiple self-attention mechanisms known as attention heads. So different models of transformers have a different multi-attention head that I would be discussing in detail in when we talk about the BERT model. And after getting the output from the different attention heads, it is concatenated and provided as a comprehensive representation. Then in the next step, layer normalization is done. Basically, it is done to normalize the output so that finally no unnecessary embedding is done in the output. Then finally, if feed-forward neural network is used, how it is used, the output of the self-attention layer is passed to these feed-forward layers. There are many layers in between, and they apply some nonlinear transformation to these representation and capture more relationship and more patterns and more conceptual embedding during these layers. Then you further have more stacked layer which are stacked over each other. And basically, the purpose of each layer is refinement of the data. They are gradually refining the representation which is embedded. Then finally, you have a output layer which is giving the final output. Then finally, after the encoder, a separated decoder module can be added at the top of it to generate the output. Because basically there are two modules, encoder and so these are the all steps of the encoder, and you can add a final module over to it to generate the output sequence. So what we can summarize the key advantages of transformers. The first is parallelization, okay, and it is using a self-attention mechanism. They process the entire sequence simultaneously using this self-attention mechanism, using the multi-head attention mechanism. Then it is better for the long-range dependencies because there is not a sequential representation. And because of these features, it is scalable also. They can handle large amounts of data with efficiency. Now, let me discuss few generative text models which are based on these transformer models because they are most popular nowadays. So I'll be discussing few text models. Actually, there are a number of models available. They are mushrooming like anything. But I would be discussing few popular and the most efficient text models. Okay. Now, what are the generative text models first? Basically, they can generate human-like text based on a given input. Okay. And again, they are using some deep learning techniques such as neural network to analyze and understand the pattern, and they are using some various natural language processing techniques. So, and what are basically they are supposed to do? So they can do variety of tasks. Like they can be used as writing. You can do with the writing sense. You want to write something, you want to write an essay, you want to respond to the email, you want to import some already existing text. They can work as a writing assistant. They can also work for creating images or creating audio or video. They can work for the information retrieval. Like you can give some question and based on that, like no basic question, like you are just getting information out of that. Like what is photosynthesis or what is the elasticity. So this is basically a kind of information retrieval that it will look for a knowledge base and try to find the answer of it. Then the most important advantage are basically translation, text summarization, and the conversational assistance. Because most of the text models they are, have this feature, language translation. You have a sentence in a particular language and you want to translate into another language. Then you want to summarize the text, which is a very popular. So you give some text, whether paragraph or the number of paragraphs, a collection of books or a book, a single book, like it depends how large the data is. And to summarize key points in that. Then various models are used for the text summarization, and it can also be used for conversational assessment. So basically, these are the key steps how these models work. The first step is basically a basic aspect of every model. You have to pre-process it. So data is clean and pre-processed and organized, which is suitable for this machine learning model. Then training is done, and basically they requires large amount of data to be trained. If you have to make the model more efficient, the more data you have, more efficient it will be. Then after the training, your model can generate the new content based on input given to it, and basically generate based on the data which it was trained. Like it can fill in the blank in a sentence, or it can give you the answer of the question. So basically, the important thing is what is the data on which you are training the model. That is the most important part. Then after generating the content, you are just looking at. So now expert can refine the model. Can model the output, what type of output is being generated, like what are the questions or what are the inputs and what are the different responses out of this. So based on the feedback of those outputs, expert can monitor it and refine it accordingly. Now let me discuss few text generating models which are very popular and most widely recognized. And one of the most popular model is GPT, which is a generative pre-trained transformer, and which basically made a revolution in the history of generative text models. So what is generative? As you know, creating the text responses, then it is pre-trained, and as I told you, a large amount of data is required. So it is trained on billions and trillions of data. Then it uses transformer, which I've already discussed, which basically will give you the meaning of the text which you are asking. So basically, there are specific type of language model which are pre-trained on large amount of data, whether it's book or article or the website or any other type of data, and making it use in chatbots, language translation, and various other applications. And there are various versions of GPTs are available, like GPT-1. GPT-1 is basically the foundational architecture, which was introduced in 2008. And see, initially also, the first model also was trained on 117 million parameters. See, because they require large amount of data to get the accuracy in the model. And it was the first model demonstrated the power of unsupervised learning. Then a second version was released next year, and which was trained on 1.5 billion parameters. So see the changes. The first model was 7 million parameters. Then the second model was trained on 1.5 billion parameters. And by taking the feedback from the first model, and it was trained on new data, and 1.5 billion was used. It was a incredible improvement in the capability of generating text. Then there was a third model introduced in 2020, and it was trained on 175 billion, which was more advanced than the GPT-2 version. But there is one more version, GPT-4. But basically, these versions they are not available on the model, which are freely available. Advanced are not available. Then you have to pay if you want to use those models. You have to pay for them, like GPT-4. This is the
Excuse me,
latest version.
ma'am.
Yes,
Excuse me, ma'am.
yes.
Ma'am, sorry to interrupt you. Ma'am, actually, some of the audiences are saying voice is not clear. So, can you switch off your camera so that the connection will be stable? Because I think camera is taking more data, so that is why
Can I
there is
stop
a
the camera?
Yes, ma'am. Just
Okay,
switch on the camera, switch off the camera so that
okay, okay,
the data will be proper and or
okay.
Yes, ma'am. Now you can share the screen, ma'am.
Okay.
Pooja Gupta, ma'am, is there any query from your side? You have raised the hand. Pooja Gupta, ma'am.
I hope now the noise is clear.
Yes, ma'am. Clear. You can
Okay.
proceed, ma'am.
So why didn't you tell me earlier?
Ma'am, actually, I was getting it clear. Some of the participants, they have written in the chat window now.
Okay.
So that
Okay.
is why. Okay, thank you,
So
ma'am. You can proceed.
should I start with the this? Let me start with the first model. Okay. So I was about GPT model. So I was discussing the first model, which was a foundational architecture.
Ma'am, please do it in slideshow mode.
Okay. Okay.
Okay,
Okay.
okay, okay. Thank you, ma'am.
So first model was trained on 117 million parameters. Then second version of this GPT was trained on 1.5 billion parameters. Then comes the third model, which uses 175 billion parameters to train the model. Because the key idea behind this training these model is the power of the large data. If you have more parameter, your model will be more accurate, and it has got more text generation capabilities than the earlier model. Then comes the fourth model, which is the latest of this GPT model, GPT-4, and it is a very much model which has improved in lot of areas. Like it has increased factual accuracy that it's going to generate. It has got more factual accuracy, more model alignment, likely to follow the user and lower likely the offensive output. It can also use the internet connectivity, the internet in real. But the problem here is because these models they are not really. If you want to use these models application, then you have to pay. But the earlier model, GPT-1 and GPT-2, they are available. Then there is a simplified model, which is basically to text transformer. It is a variation of T5. It is a multilingual to text transformer. So it has got both the model, encoder and decoder both. So encoder is used for understanding the meaning of the text. Then decoder is used to generate the responses in response to the input. And we can employ these again in various applications related to natural language processing. Then Plume is another open source and multi-purpose model available to you, which has been trained on 176 billion parameters. And it can generate text in 46 natural languages. And it also competent in programming languages. You can also create codes. Basically, I would be discussing BERT, which is a bidirectional encoder representation from transformer, which is basically a building block in most of the natural language processing systems. And it is also simple to understand. So I thought let me start with the BERT. So once you have a idea of the BERT, you have some basic understanding of the BERT, then you can use other models like BAR, which is having both encoder and so at encoder we use word and at decoder level we use GPT models. So I thought let me start with the word which is representation, which is the encoder part of the transformer. When we want to use word in some applications, it comes basically in different sizes. Like there are different models that is available, word based and word class. So word based a basic model available, which has been trained on around 110 million and it has got 12 layers and 76 units and 12 attention heads. Because every transformer basically works on the multi-head attention. So it has got 12 attention head. And there is another variation of BERT, which is BERT large, which is a more advanced version of BERT. It has been trained on 340 million parameters with 24 layers, 1024 hidden units. And it has got 16 attention head. So 4 more heads have been added this bird large. So basically, it can be used for the various tasks, but let me explain it for the text summarization. You can use BERT either for the extractive text summarization or abstractive text summarization. So extractive text summarization is simple. Basically, how it works, you have to select basically when some paragraph or some text is given, you have to summarize it using the most relevant sentences of that input text to create a summary. Okay, then you can fine tune it. Once you get embedding, is basically telling about the meaning, contextual meaning, situations and everything, you can fine tune it. And you can find basically the other things, like you can pass it to other layers, which you fine tune, and to can generate the text according to that input. So first it divides the input sentence into the two, which is called embedding. And there are various kinds of embedding. I will be discussing very shortly. Then it performs the scoring. All the words and the sentences, they have assigned some score. And based on this score, the relevant sentences are basically selected. Then after finding all the selected sentences, based on the qualities, you can find the some top sentences which are having the higher score than others. So how to use Word? Basically, I will let you know also you can use co-laboratory of the Google. All of you are having the Google account, so you can use that. I will also tell you how to download it. So you have to install the transformers, then you have to load pre-trained bird, okay, and you can use either bird-based uncased or you can use some higher model. Then you have to tokenize text and you have to run the sentence. And again, it is using multi-head mechanism, which is basically based for every transformer model, and each head is different type of relationship in the sentence. Okay, I would be discussing those heads also. Then they are projected into separate subspaces using by computing the scores. Then each attention head computing, and we are just adding score obtained from all heads and passing it through a next layer, which is a feed forward layer. So basically, what are the 12 aspects of the multi-head attention which are used in the bird base? So I'm using a bird model which has got 12 multi-head attention. The first head is which is dealing with the syntactic relationship. So basically, what is the syntactic relationship? Identifying the relationship such as subject, verb, modifier, noun, or object relationship. Like for example, in the sentence cat sleeps. The subject is cat and the verb is sleeps. So the cat is the entity that is performing the action, okay? And some this grammatical relationship here indicate the subject, which is the action. Then second is positional information. The second head which captures the positional information to find the distances and the relevance of the word in the sentences. Then co-reference resolution, which is basically linking the pronoun to the noun, like he refers to John. If you are using a sentence, like we refer the previous word using the word like he, she, it. So there is a co-reference resolution, and one head this word is handling this co-reference resolution. Then there is another head entity recognition. If you have some entities like person, places, dates in the input text, they are handled separately by the entity recognition. Then you have phrase structure, because every text is having different type of phrase structure, noun phrases, phrase, positional phrase. Okay, how these are attended the phrase structure. Like suppose the sentence, the quick brown fox jumps over the dog. Then how the structure is written, it will say phrase and a noun phrase brown fox and verb phrase lazy dog. So this phrase structure basically describe how the sentences can be split into the constituent parts. because to understand the sentence, first its constituent part must be clear. Only then it can find the meaning of the sentence. So constituent parts are integrated using the phrase structure rule. Like supposing you have a set of S goes to NP. So it's saying it consists of a phrase and a noun phrase. Then a noun phrase is further defined using a rule. So it's telling its noun phrase can consist these things similarly the other phrases. So a phrase structure is identified using the set of rules. Then after finding this rule, some intermediate representation is made for the given text. It may be either in the hierarchical form like this, using a parse tree, or maybe some intermediate representation. Now, what type of relationship is established? As I told you, the co-reference, there are different type of relationships like subject-verb relationship, like the quick brown fox, which is a noun phrase, and the verb indicates what action the subject is performing. The modifier noun relationship, the quick brown fox, quick and the brown, they are the adjectives which are modifying the noun. So this illustrates how the what are the modifiers which are modifying the other things. So this information is also required. Then object relationship like over the lazy dog, where the lazy dog is another noun phrase functioning as the object of the preposition over. So various type of relationship is find out and basically attended by this particular head. Then there is a semantic aspect because to get the meaning you have to deal with the semantic relationships like recognizing synonyms, antonyms, and the other lexical relationships. Then there's another head which is dealing with the sentence counting because there are special attention has to be paid like punctuation and the other markers. They are also required to be identified. Then there is a dependency part, like how words are dependent on each other. Okay, because this is very, very important to find the correct meaning and to find the correct context of the sentence. So dependency part is very, very important. Then there is a one head which is working on rare words. We can say sub words. So it's giving attention to rare words so that important information is not lost. Then there is a cross sentence connection because you would be having a pool of sentences. So how these sentences are related to each other. So you need a information which provides the relationship between the sentences in a particular context. Then you have a head for the negation handling. Okay, so that you can identify the correct meaning. So one aspect is handling the negation because meaning of happy and not happy they are entirely different. So unless you handle the negations, you cannot find out the correct meaning. So there is a one head which is identifying the basically negation. Then there is a spatial token awareness. There are spatial tokens basically when it is tokenized the input, some spatial tokens are added like CLS token, which is a classification token, then separator token, then there are padding tokens. So various tokens, then there are segment tokens, there are multiple sentences. So they are basically various tokens which are added while tokenization is. Then another important thing is how to vocabulary habit. This is very, very important. Supposing you are presenting a text and you are getting out of vocabulary words because how words handle these things, how tokenization is done, how the positional encoding is done. It has got a vocabulary basically. So it's basically giving the position from that vocabulary and it is very vast. But supposing you are having a text and this word is out of vocabulary, then how it will handle it? Then it will handle it by breaking them down into the word tokens because it has a word peak organizer. If divide the word is not there, then it will divide it and it will further divide it. You keep on dividing it unless you find the particular word or particular letter or particular sentence in the vocabulary. Then working on the multi-head attention, computing as because this is a transformer, computing the multi-head attention and computing the score of all these 12 attention mechanisms They are concatenated and passed to the feed-forward layer. Let us consider this example. I'll show you the output of this. This quick brown fox jumps over the lazy zone. So step one is the tokenization. Okay, so it will divide into the key. Initially, in the beginning, it has added a CLS token, then the different subwords separated by comma, then there is a separator token. So this is the first step, and it is done using the word-based tokenizer. The second step is the embedding, and it is using three different kind of embedding. Let me show you what are these three embeddings. One is token embedding, which is the vector representation of each token. Second is positional encoding. Okay, because it basically define the position, the vocabulary, that is segment embedding. Because if you are having the multiple text, then you have to basically define the boundaries of these segments also in the text. Like segment embedding will distinguish between a sentence A and sentence B. See, okay, before that, like how you can execute this code. Okay, let me. All of you must be having your Google account. So just go to the drive, then go to your drive, then right click here. See, you get options, then go to more. In more, you get option connect more apps. So I just click this, then I find, then write this word. See, collaboratory is there. I just click it. Then you have the option of install. Then you can use an account to install it. Now it has been installed. Now you are ready to work with it. So let me go to my presentation. Sorry. We were discussing about the word model. We were discussing about this. Okay, after downloading that transformer model from the word, you have to import the transformers. Okay, basically we are using PyTorch here. So you have to basically load this bird tokenizer and bird model. So this is basically using the bird tokenizer, and here we are using bird pre-trained bird unpackaged, which is basically bird based the first one. So it's not differentiating between the case of the text, whether it is in lower case or the upper. It is the base. Similarly, we the higher model. Okay. So we pass the sentence. We pass the sentence. Quick hop jumps over the hop. You see the output because we are finding tokenizer. Okay. And this is the first one. Quick brown fox jumps over the lazy dog. And it is making certain embeddings. CLS token in and the separator token in the last. And this is basically the positional encoding, the first one. You say some number is assigned. What is this positional encoding? Basically, it is just taking it from the vocabulary word, the position or the number of the word, where this sentence is present. Then there is a attention mark. Basically, it gives a value 0 to 1. If you find the word important, it will give the 1, otherwise it will give the 0. And supposing you are having more than one sentences, so you just look at this example. My dog is cute, and another sentence is he likes playing. So what it is doing first token embedding. So every word is divided into the token, and this playing using a word piece tokenizer and dividing into play and ing. Okay. Then there is additional embedding, like some position is given. Then there is a segment embedding, like these words, the token of the first sentence. They are in the segment A, and the tokens of the another word, they are in the segment. So if there are multiple sentences, the segment embedding is also there. Then after the initial embedding, it use the different layer of the transformer to apply the concept. Okay. Then they are passed. Then which is there are 12 in the bird based and there are 20 layer in the broadcast model. And basically, every layer is refining the output. Whatever input is getting from the previous layer, it's refining it, and we are getting the more refined conceptualizing information. And final embedding will produce the actual meaning of the sentence or the word which you have passed, which is the top one. Then what you can do is whatever you are getting out of this, that can be passed to a decoder. So what you can do basically, you can create additional layers. You can fine tune the model. You can add additional layers for the another task. And different model can be used. It's up to you which model you want to. Okay. Like see, this is the last hidden layer. And there are 12 layers in the BERT model, and every layer is adding some input. So if you see the output of the last hidden state, I show you like this. It is some numerical representation. It has got a fixed size of every token. And accordingly, size is fixed in the bird base, some different size, and in bird class there is a different size. So basically, if you start working with the bird model, you can get a basic understanding of these transformer encoder part is what. Okay. So after getting a basic understanding, you can start working with the bot model, also, which is basically having both the parts, encoder as well as decoder. So I think let me discuss some limitations also of these models, because whether we are a user or we are a developer of models, we must understand what are the limitations of these models. Okay. The most important limitation which I find is the non-determinism. If you are using a model, sometimes if you give an input, you can get a different output. Okay, which is leading to the unpredictability. Okay, so this is the one of the most like familiar disadvantage or limitation, because you have to find actually what is the correct output. If you're getting the different input from the same input, then how do you verify it is the correct input, and how do you verify it basically? Okay, and sometimes there are misinterpretation also. And actually, most of the model they are not providing you the source, so you cannot verify the accuracy of the information. And sometimes they are biased because they are reliant on the data on which they are trained. So that's why model is trained on a large data is more accurate. So large amount of data is required to train these models to remove the bias. Then another limitation is the limited use cases. because mainly these text models are for the natural language processing application. Okay, and you cannot capture the all aspect of the human life. So there is significant gap between the capability of the current system in solving the real world problems. And because they are predicting the human behavior, there are various challenges faced while generating these next generation models. Because there's a famous scientist, Jan LeCun, is a pioneer in the field of artificial intelligence. He always placed some concerns about the limitations of these models. According to him, they lack the intuitive understanding of the world that the human possesses, because which is very, very crucial for making the morally and the socially responsible decisions. Another one is real world understanding through the data. Because what we are doing, how these models are working, we are providing a large amount of additional knowledge to these systems to understand the real world. So they are understanding it through data. They are not human beings. Okay. So basically, it's very challenging so that they can truly understand what is the actual meaning or what is the intended meaning or what is the actual situation in the real world. So multi-domain data is required, and it's not easy to capture all the data because it is very challenging to train the machine for all possible situations. So this is a real challenge to understand the real world situations. Then again, it is basically human to machine interface. So whether it's a advanced to advanced AI system, we can say it's not perfect. Why it is not perfect? Because life is not engineered. It just happens. So we cannot say it can handle all type of situations or all the scenarios, all the social world issues, all the real world problems. Even there are limitations. Now, it is another important aspect of a natural language generation system, basically ethical responsibilities. Whether you are using it as a developer or you are using it as a user, you have got certain ethical responsibilities. The first important is data privacy violation. Because this data may contain some sensitive information. You are training the model using a vast amount of data. Okay, and it depends what type of data you are using and what is the source you are collecting the data from. So it might contain some sensitive data. Okay, like name, address, Aadhaar number, or other things. Okay, so you have to basically what you have to do, either you remove this data or you have to apply some mechanism. You cannot share this data with the in public. Then you have to respect the intellectual property, be sure to comply the copyright laws and plagiarism. Okay, because you are using the vast amount of a data, then avoid inputting the copyrighted material to generative AI tools. Because if you are a developer, you are using a large amount of data, then you have to be very sure to respect the intellectual property rights. If you are referencing the work of others, then be sure to provide the proper attribution. Then there should be a transparency. Okay, it should be open to all how these contents are produced. See, I already discussed. Another is independent verification of facts, and it is called also called third party fact checking. So it's basically verifying the accuracy and credibility of the generated content because we are trying to mimic the human behavior. They may not always be accurate because it is not so easy to mimic the human behavior. So it is very important to check these facts independently, whether the data generated is accurate or not according to the provided situation. There are certain considerations which you must consider basically, like as I've already discussed, to avoid sharing the sensitive information. You have to use with the caution. You have to provide the clear, concise directions or instructions because still there are not defined policies, these tools. The administrator and educator are still working on developing policies for the generative AI. So supposing you are instructing your student to use tools, then you have to provide the clear communication, what are your expectations, make them aware in all these, okay? And just recognize the tools are not perfect. So you have to use them according to your needs and try to avoid all these things which might be harmful or might create problem later on. So basically, I would like to introduce you before conclusion. I would like to introduce certain generative text tool also. Like most of the people are using ChatGPT, but there are other Indian tools are also available. So I would appeal all of you to use those tools which are designed by the Indians, like Bharat GPT or Anuvadini. Okay, let me show you. I think I have it on my system. See, this is Bharat GPT. You can log into your account and you can start working in it. And similarly, there is a Anuvadini, which is developed by the Ministry of Education by AICTE, Buddha Chandrasekhar and its team. And it is very, very useful. See, you can see there are so many modules available to this. You have Buji, which is a small but powerful online document translation tool. You have a Chutki, you have Ananta, you have voice-based multilingual form, you have video translation. See, this video translation tool is very, very powerful. You can generate a video of one language into another language. Supposing you are looking at some YouTube video and it is some in different language, but you want to use it, then you can perform the video translation also. So it's a very useful tool. You can use. There are variety of tools. You have to explore them actually because they are also basically making the people to learn. They are asking you feedback also. They are asking people to use these tools and send the feedback to these people so they can improve upon these models. Because unless you use them and send the feedback, they won't be able to improve it. So I request you to try to use these models. And if you are using basically these models for the research purpose, there is a model called perplexity. Let me show you that model. This is perplexity model. Actually, what is the advantage of using this? It is providing you source also. Like I ask something, say I say, what is bird? See, I get the answer, and along with the answer, it's providing you various source also. See, these are the source provided along with the data. So if you are using these models for the research purpose, you can use this kind of models, which are basically transparent. Okay. So it's trying to provide you the source also. So you can refer this data has been taken from this particular source. So you can avoid plagiarism. Okay. So finally, I would like to conclude it, and we can say they have got the exciting possibilities. They have numerous possibilities. You can devise the models which can work various exciting tasks, which are basically the task of the human capabilities. Because now various advancements are being made in technology, and we are getting the more advanced model day by day. So, and the future of generative AI tech was great promise, and the model evolve and improve. Okay, but I just request all of you to use these models basically responsibly and ethically. Thank you.
Thank you so much, ma'am, for such a knowledgeable, enlightening, and interactive session. Your expertise has truly opened up new perspectives for all of us. Thank you once again, ma'am. The session is open for questions now. Please raise your hands for questions. We will unmute you, participants. Please raise your hands if someone want to ask the question. We will unmute you for the same. Anjali Nayak ma'am. Yes, ma'am. Anjali Nayak ma'am, you can unmute
Yes, can you
yourself.
suggest some good book for this, which will help in implementation aspects and in basics. Good book for this.
Ashna
Thank you.
ma'am, Anjali ma'am is asking, is there any good book to refer for this?
Okay. There are many books actually and many tutorials available. So, Rakhi, can you give me my email address to these people who want to work in these areas?
Yes, ma'am,
So,
we will provide. We
I
will
will send you
provide.
the reference material also, how to use the bird and how to install it and how to use it and some basic programming techniques. I will send all of these things. So, you just take email address from Rakhi.
We will share the content with all the participants after completion of this FTP. Any other participant want to ask? Yes, participants.
Thank you very much, everyone, for listening me so patiently. I
Thank
have
you,
tried to
ma'am.
share basically the basic concept behind this idea. So now you
Yes,
can build upon.
yes, ma'am.
If any further assistance is required, I'm available. Please, you can contact me on my email, okay, for any further assistance.
Yes, ma'am. Thank you so much, ma'am. Thank you so much for accepting our invite. And I think no more questions are there from the participant side.
Thank you, everyone.
Very informative session, ma'am. Thank you so much once again.
Thank you.
Okay, ma'am. Participants, now we will have the second session after 5 minutes. At 11:30, we will start the second session. You can have a 5-minute break before this. Thank you.